All right, I think it might be time to get started.
Awesome. Thanks, Dan. Hi, this is Caroline Griffin with Riot. I lead events and operations for the Riot organization. I'm super excited to have Mariano and Dan here with us today from Particle. Particle has been a sponsor of Riot for a few years now, and they're just a fantastic organization. So I'm really excited for you to learn more about them today. Just a few quick rules. This is being recorded, so please, you will be able to find this later on Riot's YouTube channel. If you do have any questions, we encourage you to use the group chat box. Dan and Mariano have graciously agreed to answer some of those questions in line, or we'll make sure that those all get answered at the end of the presentation. But without further ado, I will give it over to Dan and Mariano. Thank you so much for joining us today.
Thank you. All right, so welcome to the Lunch and Learn today with myself, Dan Kuba. I'm a solutions architect here at Particle. I've been on the team for just over a year now. I come from an electrical engineering background, and I've worked in the agricultural, medical, and industrial automation spaces. And I'm joined by my colleague Mariano, who I'll let introduce himself.
Thanks for joining. I'm Mariano Goldwolf. I'm also in the solutions architecture team. My background is in both hardware and software, and helping customers get IoT products to market successfully.
Awesome, thanks. So today, just a quick agenda of what we're going to talk about. We're talking about some of the best practices for implementing an IoT system using cellular connectivity. As you can imagine, as a provider of some of these solutions, we've seen a lot of different deployments that our customers have gone through, and we've found a few things that we find pretty critical as you might be going through this journey yourself. And then I'm going to hand over the mic to Mariano, who's going to talk a bit about what we call Asset Tracking Plus, a definition of that, and talk a little bit about Particle's offerings there. And then at the end, we're going to conclude with a Q&A. So to get started here, I just wanted to give a little bit of an overview. Obviously, you all know what IoT is, but I wanted to drill into the different layers of what an IoT system looks like and talk a little about where Particle sits within this ecosystem. So as you know, IoT is very broad. We like to break it down into three key layers that I've illustrated here on the slide. The edge is going to be the equipment that you have on the ground. This is going to be any processing power that you have behind that, any application-specific pieces of whatever your deployment is, like actuators, sensors, those sorts of things. And then you're going to have your connectivity layer. This is going to be any wireless technology that you use. So we've shown a few here, but obviously there are many more that are used in these kinds of deployments. But it's going to include that technology, whatever connectivity provider may be offering that, any infrastructure or backend networks on that end. And then finally, in the cloud, this is where you're going to handle any of your fleet management, device management, where your data is going to be stored or possibly analyzed. And then on top of that, wherever you're going to offer your customer and user experience, whoever that may be, internal or external. So specifically, we play in a space that we call embedded cellular IoT. And what that looks like is mostly low power devices and a mixture of data flowing back from those devices, mostly processed by cloud technology, so some sort of cloud compute. Specific differences between the generalized IoT field. At the edge, these devices are typically going to be battery powered. They're going to have limited processing and decision-making ability, so they're not going to have machine learning algorithms, but they're going to have some maybe statistical algorithms running on them. And then on top of that, most of these deployments are going to use a higher mix of sensing versus actuating. So most of this is going to be data collection. At the connectivity level, we're going to leverage cellular networks because of their ubiquity and cost. They're very cost effective around the world. And then on top of that, we have our cloud, and that's going to be mostly about decision making, as I mentioned before. So where does Particle play in this field? Our niche is really to enable embedded cellular IoT deployments by combining different proven technologies across this IoT stack that I've highlighted here. Our main goal as a business is to enable customers to be focused on their use cases and what their core competencies are, rather than having to design this entire connectivity stack from the ground up. This is all a mixture of things that we've designed and that exist on the market. And there's just no need for you as a business, if you're not going to become an IoT provider yourself, to design this stuff on your own. So specifically some details about what we offer. At the edge, we have some integrated modem, microcontroller, and basic hardware into these modules that we sell. And this just makes your deployment super easy, so you don't have to go and design this hardware and communicate with these vendors. We offer multiple SKUs that allow you to work around the world with different regionalities. And then on top of that, we've built our device operating system that abstracts away some of the hardware and provides the hardware abstraction layer that you're probably used to working with. At the connectivity side, we're a services provider. We provide first-party SIM cards if you buy one of our devices, and that service is provided through our own MVNO service. And that's going to allow you to connect to 200 connect in 200 or more countries and territories worldwide through different roaming agreements that we have. And then on the cloud side, we have our own cloud. And this is going to be considered sort of the end of the data pipe, going from the edge to the cloud. Mostly you can think of this like a pipe. This is where all your events are going to flow, and then they're going to flow out into a third-party cloud. So you can see I've highlighted here that data visualization is not really something we do. That's usually something that's left up to our customers. We're starting to get into some analysis and alerting with our new asset tracking product, which Mariana will talk about at the end here. But in addition to the data pipeline, we've also built some firmware management and the fleet diagnostic piece of our platform on top of that. But again, the rest is up to you. We just sit in the middle, sort of you bookend us with a solution. So you build hardware using our stuff, and then you add your own cloud on top of that. So Caroline, if you wouldn't mind throwing out the first poll question here. I'm curious to know of the audience here, what is your experience with Particle? Have you worked with us before? Have you heard of us? Or is this the first time you're ever hearing of us? Awesome. It's great. Seems like we've got a good number of new folks, which is really exciting. I'm really excited to present to you today on behalf of Particle. So I'm going to close the poll here and continue. Thanks for your answers. Oh, perfect. All right. So 1 second. So as I mentioned, we've seen a lot of IoT deployments, and I want to talk a little bit about some of the best practices that we've found as you go and select an IoT vendor. I'm going to talk a little bit about what Particle does in these different areas, but again, I really want to present this in a way that this is knowledge that you can take out into the world when you're looking at an IoT vendor or thinking about your own IoT deployment and how to integrate these different practices into that. So the practices at a high level are managing devices as a fleet, building diagnostics in from the very beginning, and then also making sure you're using the right tools for development and manufacturing. So I'll ask another question here because there's good context for this. I promise there won't be too many of these. Caroline, if you wouldn't mind launching the second question. I'm just curious, a lot of you are new to Particle, and I'd really like to know how large your IoT flights are if you have them. And of course, there's the escape hatch if I don't have one today, and that's totally fine. Awesome. This is great. Seems like we've got a good mix of different deployments. That's exciting. All right. So let's dive in here. Managing devices at scale. It's very natural as you begin your development process to manage your devices individually. Potentially they're sitting on your desk. You have close access to them. You're going to set up things like your event stream, things that are flowing back and forth between your devices, any cloud integrations that you have with third-party services, whatever firmware is running on that device. It's very easy to manage all of this when it's sitting on your desk. However, when you go out into the field, it becomes much more difficult to manage these aspects in the same way that you might have when it's physically located next to you. You're going to lose this physical access. You're not going to be able to go out and reset the device if something goes wrong. You're potentially going to need to harmonize your firmware or any configurations that the different devices have across your entire fleet, or perhaps subsections of your fleet for different customers. And then also downtime becomes extremely critical, because at the point you're in the field, suddenly these devices are now customer facing, or they're actively collecting data that you need. And so there's no room for error once your fleet reaches a certain size. So seeking out a sustainable way to manage hundreds, thousands, potentially tens of thousands of devices is absolutely critical for a successful IoT deployment. So thinking about this, you just want to take your device management up a level. You want to think about how to manage these things in one place versus in a number of places equal to the number of your devices. So we like to think of this, and we call our product here Particle Products, and this allows you to manage devices as a fleet. And I've illustrated sort of the way that we think about this in the bottom right here. And this is taking all of these different pieces of management and combining this into a high-level abstraction that you're able to manage your events, your integrations, whatever groups of devices and different configurations between that, and then of course your firmware management. So fleet management tools are absolutely going to be a critical piece of any IoT platform or vendor that you go and supply. You want to make sure that they're going to support you in not having you waste a lot of time or spend a lot of time on device management. This should be an easy process. So as you're evaluating IoT platforms, look for features like this. This is really going to save your operations team, your development team, and your support team a lot of time. Let's talk a little bit about diagnostics. So I've sort of illustrated the IoT stack here again with the edge, the connectivity, and the cloud layers. As IoT deployments become more complicated with more different layers of processing and different technologies, the number of layers that are in between this is ever increasing. However, when there's an outage, let's take a hypothetical, you go look in your database and you notice that there's missing data for one of your devices. How do you know what layer that error is occurring in? Is it at the edge? Has your device run out of battery? Maybe it's run out of memory. Has it disconnected from the cloud? Is it at the connectivity layer? Maybe your connectivity provider is experiencing an outage, or maybe your SIM card has hit its data limit on accident. Or possibly it's in the cloud and you have some sort of misconfiguration and data has stopped flowing into the systems that you would expect them to be. So when you experience like an issue like this, it's absolutely critical to figure out at what layer this issue is occurring. And find that as quickly as possible. This can affect your ability to deploy. Maybe your issue is happening as you're putting your devices out in the field, or maybe this is while they've been running for over a year and it's affecting your customer experience. So we always want to encourage our customers to build diagnostics in from the very beginning. Think about the things that are critical to your fleet deployment and things you want to monitor out in the field. Make sure you build that up front before it becomes a problem. Because let's be honest, an outage is going to be inevitable. Don't wait for there to be a problem before you go and instrument these things. So I'll highlight sort of the way that Particle thinks about this. We take a two-pronged approach. We look at connectivity and the device's view of the world, and we call this device vitals. This is something that allows you to report back any information that the device sees about itself. So this is like free memory, what the state of charge is the battery charged? Those sorts of things is what cell network am I connected to? And so this is a device-centric view of the world. And this can be extrapolated to any IoT fleet, thinking about what your device sees. You want eyes on the ground from your device's perspective. And then on the other side, looking downwards from the cloud, looking at the different layers that are integrated into that, and also what connectivity looks like from your connectivity provider's APIs and interfaces. We have an interface called Fleet Health that allows you to manage this from this level as well. And a combination of these two systems with these two views can give a pretty good indication of how the systems are functioning across this IoT stack. And if something goes wrong, it's a great way to figure out what layer something is occurring in. So this is just, of course, one way to accomplish this. By no means is this the only way. But the key thing to remember here is think about these diagnostics upfront and make this part of your development process because it can help to save you absolutely critical time in the inevitability of an outage. Development environments. Let's talk a little bit about them. This is often the first thing that you're going to come in contact with after you've got your hardware on your desk. Unfortunately, a lot of vendors make this somewhat difficult. Either you have to use a clunky old IDE that they designed 10 years ago, or maybe you're expected to cobble together your own solution using a text editor, some make files over here, some scripts, and maybe you're interfacing with a black box, compiler or tool chain that the vendor has provided for you. Possibly you may be new to embedded development, and this is just a really overwhelming process. At the end of the day, thinking about this from the beginning, developer time is really, really valuable, and you want to make sure that this is something that you evaluate as you go and look at different vendors. How are they going to support your development efforts and make this process easy? Because you don't want to spend your time fighting against tools. That's not the development experience. The development experience is actually building the thing you're trying to build. So, of course, there's plenty of developer-focused IDEs on the market. We have personally built our system on top of VS Code, very popular IDE. And this is sort of the one-stop shop for all things Particle. But by no means is that the only approach. But you want to evaluate these carefully and make sure you involve all the stakeholders in the chain when you go and make a selection process here, and make sure that you're actually being supported. Now, looking at the other end of things on the manufacturing side, once you've done your development, this is often a not thought about experience. Sometimes it may seem easy to extrapolate the developer experience to the manufacturing line using some of the same tools, potentially some of the same scripts to do programming or things like that. It really doesn't work that way. And in order to have something successful, you need to really take into the view of who is actually going to be doing this work on the line. It's potential that you have manufacturing that's out of region, and you are manufacturing where you cannot connect to the internet. It's also possible that you have some low-skill workers who are assembling your product for you, and they're not familiar with your product in a way that would enable them to, if something goes wrong, diagnose what's actually happening. So making sure that your vendors are going to support you in this process is another thing, along with development environments. This is sort of along the same lines, making sure that you have the support that you need in order to actually go and successfully manufacture your devices. You want to make sure that you're creating a automated process, keeping humans out of the loop as much as possible, and making sure that your process is deterministic and repeatable as well. So asking your vendor about how they support you in this process is absolutely critical to make sure that you're going to be able to go through this and actually get the thousands of devices you actually want to make out in the field. Your vendor's not just there to sell you the devices, they're actually there to support you as well. So a quick note, Particle does offer a command line interface and an open API, and these are the ways that our customers typically will interface with our platform on the manufacturing line, making sure that they can claim devices, they can add things to their products, or even test their devices out. So in review, the 3 best practices, again, are managing devices as a fleet, making sure that you're taking advantage of any high-level functionality that your IoT vendor provides, making sure you build in your diagnostics from the start, both thinking about what diagnostics you might need in the eventuality of an outage, and also making sure that that system is built in. And then finally, making sure that you have the support from your IoT vendor for your development efforts and also for your manufacturing efforts. So I'm going to transition over to Mariano for the next part of this webinar about Asset Tracking Plus. And while we do the switch here, I wanted to pose another question. Caroline, if you wouldn't mind launching that. I just wanted to know, have you ever worked with an asset tracker before? Maybe this is part of your IoT fleet. Maybe it's just something you've played with. We're curious. All right, thanks for your answers, everyone. I will hand this over. Thanks.
Okay, thank you, Dan. So next I'm going to talk about asset tracking, and specifically what we mean by Asset Tracking Plus. I will then give a short primer on some common concerns around how to power an asset tracker solution and the different strategies available to maximize battery life. So Asset Tracking Plus is the idea that no 2 applications are the same or exactly the same. Some of the needs are common across applications, such as GPS to figure out where the device is, connectivity to report the location, and a way to display an asset location. But then different use cases have different needs. So applications will need to track the location of something, and possibly they also need to collect some data, or maybe control an actuator, always to achieve some sort of business goal. For example, if we're tracking the location of grain, we will want to collect data about ambient conditions, such as humidity or water quality. And this is in order to achieve loss prevention, so that the grain doesn't go bad, doesn't spoil, essentially. But if you're a company that's making a fleet of e-bike or e-scooters for rentals, then you will have different needs. You will need to collect data on the battery charge of the vehicle itself, measure impacts, for example, big drops if the users are misusing the scooter. And also you need to do some controlling of the device. You might need to lock and unlock an actuator. You might need to turn the siren on if somebody's moving it without unlocking it first. Or you might need to turn on the light. Now, this list is not exhaustive, but you can see that while an asset tracking solution might get you 80% of the way there with location and connectivity, it's important that you choose a platform that lets you easily and securely customize the last 20% for your specific business need. So what we're introducing is the Particle Tracker 1, which has an industrial grade M8 connector port. It allows you to connect, for example, to vehicle systems via CAN. Also to external sensors can be attached to this port. You can even power the device through the M8 connector. As I mentioned, we expose the CAN bus. We also have serial connections such as UART, I2C, and GPIO pins so that you can attach different things to meet that last 20%. So as a result, this gives you a large degree of customization just by reconfiguring or reprogramming the Tracker 1 from the device management console that Dan showed earlier, and adding an external cable harness to attach the device to another system. You can also add a custom application to the Tracker 1 by using the extensive list of libraries available for Particle products. And you don't lose any of the built-in functionality for location, sleep, and configuration services. So I'm going to have another poll here and ask how your project is powered. Caroline, if you could put this question up. Okay, so we have some responses coming in. It seems that most of the responses are in battery to last at least a few months, although there's recharged and plugged into vehicle as well. So I'll end the poll here. And I'll go into some of the things that you need to consider when you're building a device that is battery powered. So if you're building the battery powered asset tracker, there are a number of variables that you need to consider. Design choices will be a trade-off between functionality and battery life. Some of the variables to consider are battery shelf life and capacity. Obviously, a larger capacity will last longer, but it will cost more, way more, be larger. So one big decision point is whether to pick a rechargeable battery, such as a lithium polymer, or a non-rechargeable primary cell, such as alkaline or lithium ferrum. Rechargeable has the advantage of lowering battery and maintenance costs by not having to replace the batteries. On the other hand, rechargeable cells have a higher self-discharge rate. So primary cells will be necessary if you want to achieve a year or longer battery life from your asset tracking system. The next variable to consider is wake-up sources. And the sleep cycle will be very dependent on your use case. So I will go into more detail on their own slides. The goal when maximizing battery life is to have the device spent most of the time in sleep, but choosing the right sleep mode is key. Some sleep modes, for example, might consume a little more power, but keep RAM powered up, maintaining system state. This might be beneficial for your application, as you could, for example, make a partial wake up without the cellular radio on to collect data over time, and then upload the data at a later wake cycle. Since the modem uses the most amount of battery, this kind of application will preserve battery. Again, you need to make sure that your asset tracking system can support these kinds of decision points, whether you're doing a partial wake up or a full wake up. So in the previous slide, I mentioned the wake up sources as an important variable. So this one has quite a few trade-offs and will be highly dependent on the use case. So in the left, we have an application where we only need to publish once per day, once per hour, or essentially just a time period. For this use case, then the only peripheral that needs to stay awake when you're asleep is the real-time clock. all the other ones can be shut down. Since the real-time clock uses little power, this will usually be the lowest sleep power consumption case. In the middle, we see an application that also wakes up based on time, but it will also need to wake up if the device is moved. This can be accomplished with a tracker that has a built-in accelerometer. For this use case, you will need a sleep mode that keeps the accelerometer as well as the real-time clock powered on. So we'll use slightly more power than the real-time clock only. On the right, we have an application for equipment that needs to interact with a user's smartphone. In this case, we want our tracker to keep advertising Bluetooth, BLE beacons normally, or BLE capabilities, so that the smartphone can connect and wake up the device when a user walks up. Using the BLE radio uses a little bit more power, but it enables a very powerful application. The particle tracker allows you to select the right sleep mode for your application. So you will only use just as much power as you need to maximize battery life while also being able to do the application that your business needs. Another way to extend battery life is to use a tracker that can wake up and collect data without going into full power mode every time it wakes up. For example, you might have an application when you need to log temperature every 30 minutes, but you do not need to publish it to the cloud on every wake cycle. Maybe you accumulate the data and send it once per day. Maybe that's enough. Or maybe you just need to publish an alert when the temperature is over a certain limit. Again, since the cellular radio uses most of the power, if you use a tracker that allows you for that partial wake up, you can really extend the life of your battery. So the particle tracker system gives you the APIs to customize the duty cycle and wake modes exactly like you want it. By using sleep mode that maintains processor state, you can collect data throughout the day and only power up the radio when necessary. So many times the trade-off is made on whether you buy something off the shelf and live with the decisions that the manufacturer made, or go through the work of building your own so that you can have exactly what you want. The particle tracking system gives you the option of both. The tracker, I mentioned the tracker 1 earlier. Here on the right, it gives you a way to immediately deploy hardware to the field. You can even customize it with the M8 connector, as I mentioned. And of course, all of the software can be configured or customized through our console. If you need even more customization at the hardware level, on the left, you see the tracker SOM. That is what's inside our tracker 1. You can use that and solder it directly onto your own hardware and put any peripherals and hardware that you need. Both of these make use of the tracker services so that you can get to market as quickly as possible. So next we're going to do some Q&A. I think we have some questions that came in during the presentation. So Dan, are you?
Yeah, so we've got a few questions here.
So let me ask you the first one that I see here. So regarding your presentation, what are the most common issues your team sees when a customer goes from 0 to 1,000 units?
So I think, a lot of the things that I highlighted in the presentation are really key. So, not building in your diagnostics, not thinking about the way that your fleet is going to act in the field. I've seen a lot of customers make an assumption about how, what environments their devices are going to experience, and not building in proper tests when things are on the bench and you go out into the field and you drive 3 hours out into the wilderness. You put your device out there and you realize you did not actually test it thoroughly. So making sure your development process really uses test-driven design, making sure your diagnostics are built in, and not being the only person who looks at your code. It's kind of a silly thing. Peer review is really critical. Even when we're building things, we love to go back and forth with our team and make sure that we're actually making sense when we write our code. Let's see, what else? Certification and antennas is another really big one. A lot of people forget that that's a big problem. Sometimes, in your design, it can be really challenging for you to make sure you're planning for that. Maybe you don't have the experience. We try to make that easier on our customers. Our devices come with a set of certifications and an antenna that's already certified with it. There's still usually a process you have to go through to make sure that you haven't added anything to your devices that is going to affect that certification. So just making sure you're still under the certified levels. But planning ahead for that is a really critical piece as well.
Okay, I see there's a question here on where security comes into play with respect to edge, connectivity, and cloud, and also in development, deployment, and management. So if you want, I can take that one.
Yeah, sure.
So security is built into our device operating system at our factory. So we have security between our device, what we call device OS, the operating system that lives on the device, and our cloud. That is based on TLS. In our case, we use DTLS as we're using UDP, which co-op is based on UDP for the communication to the particle cloud. The keys or the certificates for that DTLS are installed at our factory. And if you develop a custom application to go on our device, you don't replace device OS. So in our flash, we have a partition for device OS, a partition for for your application. So the security is built from the ground up to our cloud. And then if you want to get the data over to your cloud, we use standard webhooks or integrations with Google or Azure as well. And those are all protected via TLS, of course. And then over-the-air firmware updates are all done via the already encrypted co-op interface that I mentioned.
Awesome. Thanks, Mariano. I see a question here about impact of end of life for 2G and 3G. You mentioned 2022, so I think that's probably for the US guidelines here. We know in 2021, these networks are going to start going offline, and throughout the year, even us who have relationships with the carriers, they're not going to tell us, this tower is going to go off at this time. So it's hard to plan for this if you have an existing deployment in the field. It's absolutely going to impact the global IoT market as well. Sunsets are starting to be planned all over the world in various different developed and less developed countries. So this is absolutely going to be one of the critical junctures for IoT in my mind. The radio access landscape is unfortunately fragmenting as well. So 2G and 3G, it was pretty easy to build a single SKU or a single modem that would allow you to connect across the entire world. Now that's changing because these different IoT standards are coming out, like LTE M1, NB-IoT, or even just using a lower category like Cat1 radio. The deployments of these different strategies are changing around the world, and they aren't necessarily all being rolled out. Now, because we do have relationships with the carriers, we've done our best to evaluate what the best radio access technologies are in various different regions of the world. And we have since built SKUs to support those deployments on LTE. We're actively moving our 2G and 3G customers over to LTE and making sure we have the hardware to support them. So we've got some recent products that we've come out with in what we call a pin swappable form factor. It's if you're familiar with the M.2, maybe on a hard drive or something like that board edge connector. We now offer two connectivity modules that are different than the tracker units. These are for non-asset tracking use cases, but they're swappable. So one radio supports the North American LTE Cat M1 radio access technology, and then the other radio is specifically for the EMEA region. So you could theoretically build a single SKU for your device and be able to swap out those radios at assembly time without having to solder anything. And this would enable you to support different regionalities in the world. And of course, as we look forward here, we are planning additional support for other regions in the world to make sure that LTE is supported worldwide.
Okay, thanks, Dan. I see there's another question here on hardware availability. You can buy our devices off the shelf, use them immediately. You don't even need to talk to our sales organization. You can buy them on our online store on our website, which is particle.io. You can buy them through a distributor like DigiKey, for example. And then we also have a wholesale store that you can sign up for where you can buy larger quantities, for example, trays of 50 or whatever you need. But yeah, the hardware is available. As Dan mentioned, we have pin-compatible hardware for different regions, for like cellular devices that have different regions. So all of the hardware that we showed today is available for order right now.
Awesome. Yeah, and the only thing to add there is, we do have an enterprise plan for larger IoT distributions, and on that plan, it's a little different. You would actually forecast your usage of hardware, and we will build to the orders that you need. So, anything you buy off our store and whatnot is, of course, subject to lead times and things like that. But we head that off when you're an enterprise customer with us. I see a question here about low power WAN, and I assume you're talking about LoRa. So I'll respond in kind with that. Our main access technologies that we support are, at least for full connectivity up to the cloud, are Wi-Fi and cellular. As you've seen today, the cellular piece is a pretty critical part of our platform and something we've invested heavily in. We found that most customers who work with our devices will either build a third-party, low power wide area network or something on top of our devices and use our devices as a gateway instead of having them be at all endpoints. And really, the reason why we haven't targeted those kinds of technologies is because it's really hard for us to offer our core platform on top of really, really low bandwidth systems. We've optimized our stack for low bandwidth connectivity. A standard publish only has 64 bytes of overhead, and that includes all the encryption. So we like to play in the low bandwidth state, but when you start talking about things like OTA or some of the other device management features, it's really, really difficult to do that over the extreme bandwidth limits of something like LoRa. So our devices are extensible. We've got SPI, I2C, analog, digital, all sorts of interfaces on our devices. And it's absolutely possible to hook up a LoRa radio. There are customers that do this today and communicate with an existing fleet. And the only other thing to add there is our devices do come built in with BLE. So we found that for use cases that are at least close, the sensors aren't miles away, BLE can actually be a great bridge to smaller, lower power nodes.
All right, thanks, Dan. I see another question here on what protocol is being used to send the data from the IoT device to the cloud. And let's say I want to use our own cloud. So Device OS takes care of the connectivity from the device to the Particle cloud. And then that makes sure that the data is secure all the way. And then from there, we don't store your data. You don't have to use our cloud for your business dashboards or whatever your other needs are. We have easy to use integrations. For example, if you want to use Azure, we have an Azure IoT integration. If you want to use Google, we have Google integration. If you want to use anything else, we have a webhooks, which is a REST API. And essentially, as the device does a publish, publish is what we call a device OS, a Particle device OS primitive. So it's a one line, you say particle.publish on the firmware on the end device, and the data gets published. The webhooks will automatically make that REST API call to whatever cloud you want to use. So you can store your data. You can do anything you want there. But what you don't have to what you don't have to do on your own cloud is you don't have to do the device management. You don't have to implement over-the-air firmware updates, fleet management, like setting up groups with different firmware versions or different configurations. All of that, which is common across IoT fleets, we take care of. That way, you don't have to reinvent the wheel for every single project. So we take care of that, and then you get your data in your own cloud via webhooks or integrations, and you do that last 20% yourself.
Awesome. I see there's a question about standard levels or service level agreements in regards to uptime in the Particle Cloud. This is something that we do offer to our enterprise clients. We have our own SLAs associated with our cloud, and that's part of the agreement that you would make. However, that is reserved for our enterprise clients. That's not something we offer to just standard developers or people scaling in the system today. But yes, we do have those. I also see a question about promo codes or discounts. I know we don't have any ongoing promotions at the very moment right now, but if you do sign up for our emails, you can go to the Particle website, and we have our own store. You can just go to store.particle.io. We've had quite a few promos this summer, so I imagine we'll continue to do that. I don't know off the top of my head when the next one is coming, though.
I see a related question to the SLA is how much would I need to charge my customers monthly to break even, assuming 1,000 units. So what I would say is contact our sales organization for that. Can have a conversation on the cost for a volume and enterprise deployment. If as far as if you're a developer without an enterprise plan, you can go to our website and see what the monthly charge for each device is, and that will depend on whether it's cellular or Wi-Fi or asset tracking. But for 1,000 unit type deployment, I would definitely contact our sales organization, and somebody will be able to give you a better quote on that.
I see a question on Particle device data and whether it is always flowing through the Particle cloud or not. So the Particle cloud was designed with this idea of messages or publishes in mind, and that's bidirectional. This is to a device and also from a device. And we've highly optimized our communication strategy over the co-op over UDP strategy that Mariano was talking about. We've really tried to heavily invest in making this as low data as possible. We know how expensive IoT data can be, and also, sending lots of data is a power intensive piece of any system. So those are the pieces that we've really optimized, and that data flows through our cloud. You're able to see those events in the cloud. You're able to push them out to external systems. However, our hardware is open, and you can initiate a TCP or UDP connection to an external server. There's nothing that we're going to do to stop you from doing that. The only downside to that is it does go around the pieces of our platform that we've carefully designed, like the encryption piece, things like retries. We've tried to make our system as reliable as possible and narrow it down to a use case that's usually the thing that our customers want. But again, we're not going to stop you from using our devices in the way that you intend to. So you can look in our docs. We've got documentation for our TCP and UDP libraries. And sometimes people use that for like a large data transfer. You need to take an OTA update to a third-party processor and need to download that file. That's typically what people do with that.
Okay, I see a question on how often we release updates or new versions of the platform. So we have, we're introducing this just in the next month or so, what we call the long-term support for firmware. So we do release device OS updates quite often as we introduce new features or bug fixes. What we are introducing now with long-term support, just like if you're used to like Ubuntu long-term support or other systems that use that, is we will have a version that we say as long as you're using that version, we will backport any bug fixes, but we will not put any new features on it, so that you are guaranteed to have a certain amount of time where you can use this version number, and you will not have to do extensive testing in the future because there's new features added to it. So it will be two paths. There will be a long-term support, and then there will be a latest. So you can always get on the latest device OS version if you want to get the latest and greatest features.
Awesome. I think we've answered all the questions in the chat here. We'd be happy to answer any more if you guys have it, but I hope this has been a helpful webinar for you. Oh, here we got a question. Difference between the Boron LTE Cat M1 versus Tracker SOM. So the Tracker SOM, you can think of the Tracker SOM as if we've built a product on top of our product. We built the Tracker system because we have worked with a lot of customers in, well, let's take, for example, the micromobility space, things like the scooters and other rentals that you might see in different cities around the world. We've helped a lot of those customers build their asset tracking solutions for those devices. And that is a great example that I think Mariano highlighted of Asset Tracking Plus. So because we had so many engagements with those customers, we decided to build a product that was really targeted at use cases like that and others. So the Tracker SOM takes the core technology that we've built with the Cat M1 SOM and extends that with things like the GPS, the accelerometer, an onboard flash. There's a ton of features and hardware that we've built into that to make it really easy to use and have a lot of the core asset tracking functionality built in. The other difference is that the Tracker SOM can take advantage of our tracker services in the cloud. So this is the map that Mariano showed you, as well as the configuration engine. That piece of hardware has all the things on board to support that deployment out of the gate and become an easy way to just get online and start asset tracking. With the Boron, this is for when you really want to design your own product. Maybe you're not doing asset tracking, you're just collecting data from a sensor out in the field somewhere. That's really the product that you want to use for that.
Okay. Well, again, thank you everybody for joining. If you have any further questions or if you want to get started with your project, you can contact us at sales@particle.io. Somebody will get back to you and we'll talk about how to deploy your IoT project. I see, another question came in, and this is, what should I consider if trying to decide whether to start with SOM Evaluation Kit or Tracker One? So that's an excellent question. So both run the same Tracker Edge firmware, and they have the same services on the cloud, as Dan mentioned, the map and the configuration service. So it depends really on what you want to do for your project. So if you want to add custom peripherals, if you want to solder it onto an existing PCB that you already have, then you would go with the Tracker SOM, and you want to start with the evaluation board because that breaks out all the pins from the SOM. If you're looking for a device that is IP67 rated and it's ready to be sent out into the field today, then that would be Tracker One. There is some customization, as I mentioned, through that M8 connector, so you could add some sensors or something like that, but it is ready to be deployed. It has a battery in it, and it can be plugged in either through the M8 connector to, let's say, a 12 volt if it's going into a vehicle, or it also has a USB-C port so that you can charge the battery via just USB 5 volts. So that would be your decision point, whether it's something ready to send to the field now, or if you want to develop your own custom hardware.
Yeah, maybe just a quick adder there. You can think of the Tracker One product as a bridge or a reference design. This is the thing that you're going to go and be able to do a pilot with. You don't have to go build your own IP67 case. You can just throw it in there. Maybe you don't have all the sensors you want, but you're able to interface with the CAN bus on the vehicle you're tracking, something like that. It's a way to do a pilot in a successful way. And also, of course, to see how to design a product with the Tracker SOM in mind. We've really wanted to provide a reference design for customers who do want to take it to the next level and to build something custom. But absolutely no reason you can't use the Tracker One in a full deployment.
Thanks, Dan. I see there's an additional question on what is the smallest form factor available with GPS and LTE. So the Tracker SOM has both GPS, GNSS, and LTE. So that would be one option. It really depends on which in your form factor, whether you're looking at X, Y, or Z difference. For example, if you had more height space, you could theoretically use a Boron with a GPS feather. That would be taller, but it might not be as long in the X direction. So either Tracker SOM, the advantage of Tracker SOM is that you get all of the tracker services. You get the built-in map on our console and the configuration services, but the Boron LTE with a GPS feather will also work.
I see we've got a question here on samples with code and reference designs for the SOM evaluation kit in IDE. So we have a member of our team who's actually put together a lot of application notes around the Tracker SOM and Tracker 1 product, how to interface with sensors over the M8 connector, how to interface with some of the other low-level pieces like the configuration service. He's built a good number of examples and app notes. If you go to I think the best place to look for that is on our GitHub, right, Mariano?
Yeah, in our GitHub or our tutorials as well. There's a link to a lot of them. So I will put that link here in the chat.
Perfect. Yeah, I think he's written 20 of them to date. So you've got quite a bit of things to take a look at. I see another question here about collecting product-specific telemetry data. So the thing about our products is we don't tell you what kind of data to collect. You can think of us just like a pipe that gets your data, whatever it is, from your sensors and your actuators out into the cloud. We tried to solve that piece for you. So if you want to interface with something that is a proprietary system, I mean, let's just take a commercial vehicle, for example. You want to connect the Tracker 1 up to the CAN bus and that, as long as you have access to the documentation from the manufacturer of whatever equipment that is, and you're able to go out and figure out what CAN messages to query to get the data that you want, our device can absolutely support you to do that. One of the best parts about this is you get to run your own code on top of this. We're not telling you, okay, you can only publish at 10 minutes and an hour, and you get location and temperature, and that's it. Our devices may do that out of the box, but you get to write all of your own code on top of this and make the application specific to whatever you're trying to do.
Yeah, one thing that I would mention is that with the introduction of the tracker services, we can store your data if you want to. So when the device publishes the location, we can store that for 6 months. And we have an API in Device OS that allows you to put your own custom data, so your telemetry data, into that same publish that sends the location data. So that gets put into our database if you want to. And then you can, not only are we keeping track of your telemetry data, but it's also associated with the location of the device. So your telemetry data, the location, temperature, battery, all of that gets associated into that point. And on the map in our console, you can view it. You can view what the current status of the device is, both location as well as your custom telemetry data. But you can also view historical data. So you can say, hey, I want to see the trip that happened in the last 3 days. And then you can follow along and see the points. And for example, let's say you're adding temperature as your telemetry. You can view, as you mouse over, you can view that data. You can download it as a CSV. And you can use our cloud APIs to also query that data and pull historical data. So for example, if you wanted to do your own custom dashboard that it's not our map, now with the tracker services, you don't need to store the data in your own database like you did before with particle products like the boron. You can actually use our database and have your front end or that you're designing pull the data from our database and display it any way that you want. And it's associated with the location, time, and whatever your telemetry data is.
All right. Well, if there's no more questions, I think we'll sign off here. Please, one other thing I do want to mention, I know someone had asked about, actually, I think I missed a question here, any suggestions to look at products or projects that people have done with LoRa in tandem. The thing I was going to mention there is we do have a really, really strong developer community. These are the folks that we actually grew on top of. We at one point in our history were a maker product, and we've grown now into an enterprise product as a result of that. So our community, you can access it at community.particle.io. We have a really strong forum there. It includes many of the members of our technical staff, as well as a lot of developers building really, really interesting products on top of our ecosystem. So if you want to look for example projects there or ask questions, feel free to engage. We'd love to see you.
Really great presentation, guys. Thank you, Dan. Thank you, Mariana, for taking time out of your busy schedules to be here with us today. Everyone have a great day. Thanks so much.
Thank you.
Thank you, everyone.